Okay, now after looking at ways of finding the equation of the line in different forms, we can try out the three questions. Find the equation of the line passing through the following points. And Roman 1, the point is A with coordinates 3, negative 2, and B with coordinates 0, 5. Then Roman 2, we can see the points P and Q. And then Roman 3, the points being X and Y. Okay, so now we can continue after looking at the equations of lines. We can look at what we call parallel lines. What we know about parallel lines from our primary session work is parallel lines do not meet. Once lines are parallel, they will not meet. They will not have a point of intersection. Now, if they don't have a point of intersection, what is common within them when we look at them under the coordinate geometry? What we can say about this parallel line is one. If we have two lines, one being line 1, let's call this line 1, with gradient m1, and this being line 2 with gradient m2. What is common about these parallel lines is one, that parallel lines have always got the same gradient. For example, for two lines that are parallel, gradient m1 is equivalent to gradient m2. This is the scenario that we normally use under the two parallel lines. Parallel lines will always have the same gradients. Gradient m1 will always be equivalent to gradient m2. From here we can draw our first example, saying find the equation of a line passing through the point P, which is 2, 8, and is parallel to the line, joining, and is parallel to the line, and is parallel to the line, y is equivalent to 2x plus 7, and is parallel to the line, y is equivalent to 2x plus 7. Taking this as a simple example, the question says find the equation of the line passing through the point. The point is P. Now there is a line that is passing through the point P. Let's assume this is my point P, and it has got its coordinates 2 and 8. And then they say, and is parallel. This line does not meet another line, and is parallel to the line. This now is parallel to a line that is given in terms of its coordinate, in terms of its equation, which is y equals to 2x plus 7. Now, these two lines, this is line 1 and this is my line 2. This line 1 will have the gradient m1, line 2 will have the gradient m2. But I cannot get m1 when I have one known point. Now I come to the second line. From the second line, I have got gradient m2 that I'm looking for, but I have an equation of a line, which means from the equation of the line, I can easily find the gradient of that same very line, knowing that y is equal to 2x plus 7. When I try to compare this with the general equation of the line, which is y equals to mx plus c, knowing that m is my gradient, this means I can pick the gradient as the value or the coefficient of x, knowing that my m2 is equivalent to 2. But let's recall, under the properties we were given that talk about the parallel lines, we say the parallel lines have got the same gradient, knowing that m1 will always be equivalent to m2. And so this will give us an implication that this gradient is equal to this gradient, and that means they are both equal to 2, which means m1, which is equal to m2, is equal to a 2. Now, after getting m1, and we have a known point, like we've seen in our previous session, now we have m1 given as a 2, and we have a point P, which is given as 2, 8. From these two, we can find the equation of line 1, knowing that the equation of line 1 is going to be coming out of y equals to mx plus c as the general form of an equation, then we can easily substitute and say, if we know